Hello, in this video we are going to build the cylinder for the Wighton engine, the two-cycle gas engine. The material for this component is 1018 steel, but I chose plain carbon steel, which is low carbon steel, so it's going to work out just fine. Units, inches, pounds, and seconds, ANSI drafting standard. So after quite a while of staring at this print, I've decided to start this with a 3/4 inch square on the top plane, and I'm going to extrude it upward. And I'll explain as we go as to why I'm building it this way. So it looks like it's a 3/4 inch square, so I can type in my 0.75. I will in this case use the symmetric relation just to review this with you again. And there we go. And if I want this to be a square, I can make the length of this line equal to the length of that line. And it eliminates the need for me to add a second dimension. So that's it. That's all I want to do. I want to start out with a simple base feature, 3/4 inch square, and we're going to extrude it upwards, the total height of 905. So 905 thousandths. So there we go. And revert back to my isometric view and do a quick file save. This is the cylinder for the Wighton engine. Okay, now I'm going to add these grooves using a circular cut. And I think what's going to make things easier is if we create a new plane through this edge and this edge, and I'll explain why. If I'm going to add these circular cuts to this part to generate fins for the cylinder, this is going to be done on a lathe. So this part's going to be spinning around and rotating, and a tool is going to come in and carve out those areas. So if we sketch our geometry on the front plane and try to revolve that, it's not going to work. We're not going to be able to get the full amount. So we're going to have to generate a new plane that goes through these two edges. So on my features toolbar, I'm going to click reference geometry plane, and I'm going to choose this edge and the edge that's diagonal from it, and then click the green check mark. So plane 1 is now shown in my feature manager, but I don't need to see it, so I'm going to go ahead and hide it from the graphics area, but it does cut through the diagonal portion of my square. Now I'm going to sketch my geometry on this surface. Use normal 2 so I can sketch directly at the surface. And I'm going to start to draw the rectangles using a corner point rectangle in the areas where I want to remove material and leave it where I want to add the material. Okay, so I'm going to go ahead and adjust my rectangles, and this is going to make a lot more sense, I hope, once I start adding dimensions. You'll see how the geometry is going to react. Okay, so according to the print, starting at the bottom, our first cut is 35 thousandths. So that's 0.035, and then it's 0.1 from the bottom to here. .55. Just making minor adjustments here. This is my fault for being wrong with the scale. Okay, 5.5, and then 6.5 is the next one. and each one is 1/32 thick. There we go. Okay. A little tedious the way that it was dimensioned, but here is basically all of the radial grooves in this part. I'm going to add a relation that forces all of these endpoints or these surfaces to be collinear because they all share the same diameter. I'm going to add a vertical length center line, add my diameter, which is going to be 0.6. Okay, so now what looks really confusing, if I go ahead and revolve cut this, I'm left with the cylinder. And that's exactly how it would be done on a lathe. A machinist would start with this chunk and then using a square cut parting bit machine all of those surfaces. Perfect time to do a quick file save. Now I'm going to add the 7/16 bore. I'm going to sketch on the top surface of the part. Draw a circle. .4375, and it's +5/10 minus nothing. So I'm going to go ahead and switch this to 4 decimal places. There we go. And this would be also done on a lathe using a boring tool, and it would go straight through the part. File, save. Next, I'm going to add the 4 2-56 holes to this surface using Hole Wizard. So first step would be to pre-select the surface in advance, click Hole Wizard, and switch to a tapped hole, which is this button right here. Now make sure it says ANSI inch, tapped hole, 256, and I will leave it at up to surface and tell SolidWorks to drill and tap up to this surface. And with thread callout, I'll leave, and now I just have to position them. So I'm going to go ahead and click Positions. And I'm in sketch mode now, and wherever I put a point, it's going to place that tapped hole. But what I did was deselected my point tool, and I'm going to go ahead and add a center point rectangle. Make sure on the left hand side I'm going to put for construction. Actually, this won't work, so it's going to have to be a 2-point rectangle. And this rectangle is going to dictate the hole locations. So from one side, from one hole to the other, it's 0.51. And according to the blueprint, it's 0.12 from the edge. So I'm just going to go ahead and dimension it how they have to avoid confusion. So again, I'm on the cylinder blueprint in the top view and just kind of filling in the locations of these tapped holes. Okay, and the reason I'm doing this is I'm going to convert this square that I've drawn into a construction square so that I can drop a point onto the four corners. It's a little tip or trick or whatever you want to call it, but it's a way to do it nicely without, adding extra relations. And now I can use the dimensions that are on the print, and I know that I've got it right. And those drilled holes are going to go from one surface to the other. Perfect. So quick file, save. Next, I'm going to make a 35 thousandths flat. It says 0.035 flat with end mill on this surface here, and I'm going to sketch it on the right plane instead and show you why I prefer this method. So I just kind of anchored the rectangle in the corner as shown. Said it was 35 thousandths flat, which means this dimension is 0.035. That's the depth. Let me change that. And the width is going to be 0.125. Okay, so what's going to happen when I extrude cut this through both is it provides a flat. Okay, and that would be done in this direction like so. An end mill would come down, go back and forth, and cut that little flat. So file, save. Next, I'm going to cut the slot that goes from here to the inside of the cylinder. I'm going to sketch on this surface. Actually, I'm going to try to sketch on the front plane and cut outward and see if that works for us. So I'm going to go ahead and use a center point straight slot. And I want to make sure that I do my best to follow the dimensions on the print. And it says this is 0.156. And then this distance from here to here is 222 thousandths, which is a little strange, but let's see if it works. And then it says the diameter is 0.125, so from here to here, 0.125. And let me switch that over. Okay, and then the height is 482 thousandths, 0.482 to there. So I already noticed that there's a discrepancy. So there's my 482. I'll add the tolerance, not that it's going to make a difference, but we'll add the 3-place decimal bilateral tolerance. So 482 thousandths plus nothing minus, it kind of cuts into the slot a little bit. So what I'm going to end up doing is, for now I'm going to remove this dimension, and I want to make the slot match the flat that I put. So I really don't even need this dimension either. You know, right now I have this slot that's waiting for me to give it a size, but I'm going to cheat here and I'm going to use this geometry instead. And then we're going to cut that outward. And let's look at it from the front. And that's kind of what you'd be looking at. So we have this flat, and then inside there is the slot that was cut. And it's going to act as a port for the cylinder. So, File, Save. Okay, the last cut for the cylinder is on the bottom. So if I put my isometric view and we look and we say, okay, well there's the top, there's the front that has the slot feature. View CC, according to the print, is going to be at the bottom. So what I did was I sketched the shape on the bottom and extrude cut it up into the part 450 thousandths. So looking at the view from the bottom, this is basically the slot command, the straight slot command. The center to center distance from one radius to the other is only 13 thousandths, so it's very, very small. So it's not quite a circle. It's a slot shape. It's almost like an oval. So that it may have looked confusing on the print, but this is all you have to draw is a straight slot. Keep it centered with the origin, and cut it straight into the part 450 thousandths. So that when you're looking at it from the front view, you can see that surface through the cylinder, and from the top view, you can see that scalloped section where the end mill comes in and chews out that material for the cylinder. So then we have some holes at the bottom of the part, so we'll do those next. I'm going to go ahead and click on this surface, go to Hole Wizard, and we're going to switch from tapped hole to a plain drilled hole, and it looks like 0.086 is the dimension. I don't know what 0.086 is off the top of my head, but I'm going to go ahead and add a fraction. I'll pick something that's close to 0.086, so this one. Okay, I'm willing to bet it's either a number or a drill size, so let's see what drill sizes we have. 0.086. So there we go. It actually is number 44 drill size is 0.086 inches in diameter. So really cool. I didn't need to look up in the book or use Google. SolidWorks kind of allowed me to click show decimal values, and I found 0.086 from the list, which is nice. And I'm going to say from here to there underneath my end condition, and make sure I don't have anything else checked off, which I don't. I'm going to go ahead and click on positions. I'm in sketch mode now, and these holes I believe are at different locations, so I'm going to go ahead and place them individually just to be safe. I don't want to assume that the hole locations for these holes at the bottom match the ones on the top, and I don't think they do, but we'll find out in a second. So this is 70 thousandths. This one is 650. This one is 0.1. This is 147 thousandths. This is 0.65. And this distance is 456. So slightly different, but a little tedious, but dimensioned correctly and extruding correctly. So there we go. There's our cylinder. File, save, and I'm ready to start on the next part.